Greetings! I'm back after like a month of not posting because, well, school started and then I had this like massive cold last week, which is still currently going on, but like I feel better, so it's fine. But yeah, this integral, the integral from 0 to infinity of arctan x divided by x cubed plus 1 dx, it's a crazy integral, but I've wanted to show you it for a long time, like a month, and like there's a lot of like planning because it's stupid. There's so many steps. Well, at least I found a method that takes so many steps. There's probably a better way of doing it, but like, oh well, it's fine. Right, so this this integral is gonna be evaluated across multiple videos. I don't want to call it a series, but like this is gonna be part one of doing it. We're gonna be doing Feynman's trick and partial fraction decomposition. So just to dissect it a bit, and then we're gonna have an easier time trying to solve it. But yeah, let's get started. So Feynman's trick. We're gonna add a parameter into this integral. Where shall we put it? Well, I'm putting it inside the arctan function. We're going to get that juicy rational function. Right, anyways, so if we call this integral I, it always has this like funny title up top. But anyways, we're going to call this integral I, and then we're going to define our integral function, I of A. It's going to be the integral from 0 to infinity of arctan of ax, so ax, divided by x cubed plus 1 dx. And because we now have this function right here, we can differentiate both sides with respect to a. And because differentiating both sides with respect to a, we're actually putting like a dA outside. But by Leibniz rule, we can put the operator inside of the integral operator. So like we can switch the two operators, and the differential operator becomes a partial with respect to a. And 1 over x cubed plus 1, it's not affected. So that's going to get pulled out. And we're going to have the partial with respect to a of arctangent ax. And let's differentiate it. But first, just to say, because we've defined our function this way, our I right here, this is actually equal to I of 1. Just saying, because it should be easily seeable that it's I of 1, but just to clarify. Anyways, now we differentiate it. Well, we're going to have 1 over x cubed plus 1. Differentiating arctan ax, we're going to get 1 over, so ax squared, which is a squared x squared. Ooh, a squared x squared plus 1 times x, because of the chain rule. So we're going to have this, and rewriting it, well, in a slightly better way, we're going to have the integral, and then I've given up on using blue for a, just because it's annoying. A squared x squared plus 1 on the denominator, and x cubed plus 1 we can factorize into x squared minus x plus 1 times x plus 1. And then that's all in the denominator with x up top. And so we've got an integrand with a factorized denominator and is a rational function. And that just screams partial fraction decomposition. So let's do it. So we've got this guy in the middle. Let's copy and paste it, because I can't be bothered writing it again. If I can paste it, please. Hello? This is so goofy. Hold up. There we go. Oh, and that x isn't even... You know what, it's fine. Because we don't need it anyways. So, I don't know what this bit is, by the way. Like, this this line that goes across. I don't know why it happens when I paste stuff, but like, anyways, that happens. That we know is a sum of rational functions with these denominators. So we're going to have a squared x squared plus 1. And up top, we're going to have a linear function because the bottoms are quadratic. And same thing here, x squared minus x plus 1. Linear function plus e over x minus x plus 1, sorry. And that is a linear function at the bottom, so that's why it's a constant at the top. Anyways, we're going to multiply through by the denominator because that's usually how you partial fraction. So we're going to get ax plus b times whatever's not this, right? So x squared minus x plus 1 times x plus 1, but we know that this is just the factorization of x cubed plus 1. So let's put that in, plus cx plus d times whatever's not in its denominator, so a squared x squared plus 1 times x plus 1. And similarly, e, whatever's not in its denominator. My handwriting's getting worse and worse. What is going on? Hold up. Let's write this in a better way. E times a squared x squared plus 1 times x squared minus x plus 1. And what we're going to do is we'll have to solve for these, which is quite annoying to be fair, but we're going to do it by comparing coefficients of x to the something power. So, as an example, x to the 4th, well, we have 5 unknowns, so we need 5 equations. For the 5 equations will come from the x to the 4th coefficients, x cubed, x squared, x, and the constant. Anyways, x to the 4th. On the left, we have no coefficient for it, so it's 0. On the right, we have ax times x cubed. That's going to get us an a. Cx times a squared x squared times x will get us a ca squared. And e times a squared x squared times x squared will get us an ea squared. And similarly, oh, that's just gone down there. I don't know what's going on. Okay, anyways. Similarly, for x cubed, we're going to literally do the same thing. So 0 on the left, and then we're going to have a bx cubed up top. Let's get rid of these underlines. Bracket. Come on, please, bracket. Okay. Bx cubed, and then in the middle, we're going to have a cx times a squared x squared times 1. So ca squared is one of them. We're going to have a dA squared as well. I think, yep, that. There we go. So we have a dA squared, and I think that's it for the middle. And then we're going to have a e times a squared x squared times minus x. So minus ea squared. Yep. And for x squared, that's going to be, the first row has nothing. The second row is cx times 1 times x. So c is one of them. And then is d one of them? Yep, dA squared. And e's got 2 actually. So e times a squared x squared times 1, or e times 1 times x squared. So we've got a plus ea squared and a plus e. And we're actually going to factorize this into a squared plus 1 here, just for future purposes, wink wink, but yeah. X, we've got 1 coefficient on the left this time, finally not a 0. And then on the right, we have, let me get rid of these dots real quick. We have a, yep, a, and then we have C and D, yep, C and D. And we have a minus e actually, because e times minus x. And for the constant coefficient, we're going to get 0 on the left. On the right, we're going to get b times 1, d times 1 times 1, and e times 1 times 1. So b, d, and e. B plus d plus e. So now we have 5 unknowns and 5 equations. Remember, little a isn't an unknown because it's a parameter. We're going to set that to 1 anyways. But we're not gonna set that to 1 right now, just because it's just gonna mess things up, because we have to integrate with respect to a in a bit just to get rid of this I prime. So we can't set that to 1 just yet. So anyways, we are going to have to solve this system of equations, and we're going to do that by using an augmented matrix. Yeah, because no one wants to solve a normal, equation by hand. So the columns, they're going to be the coefficients of a, b, c, d, e. The augmented bit is going to be 0, 0, 0, 1, 0, the left part. And let's just write the coefficients in. So let's get that. The first row, a0, a squared, 0, a squared. No. Hold up, my brain is not braining. 1, 0, a squared, 0, a squared. There we go. 1, 0, a squared, 0, a squared. Right, second row. 0, 1, a squared minus a squared. Let's go. 0, 1, squared, a squared minus a squared. Third row. 0, 0, 1, a squared plus 1. 0, 1, a squared plus 1. See what I did there? Because we need the coefficients of e. So that's why I pulled that out. Anyways. Fourth row. 1, 0, 1, 1, negative 1. Yep. And fifth row is b, d, and e. So 0, 1, 0, 1, 1. And that is a horrendously placed one. Anyways, there we go. Now we have to row reduce this to finally solve for these coefficients. So let's do it. Not these coefficients, these unknowns, but yeah, anyways. Let's do it. So we want to get it into reduced echelon form. Not reduced echelon form. Row echelon form. Yeah, we don't need row reduced because that's just annoying. Row echelon form's fine. So these three are fine, to be honest. They're behaving quite well. It's just these two on the bottom. So these two ones right there. So what we're going to do is we're going to perform the row operation row 4 minus row 1. That's going to go into row 4, and row 5 minus row 2 is going to row 5. And that is going to be quite good because it will get rid of the 1. So let's do the first one first. Row 4 minus row 1. So that's 0. 0, yeah. And then 1 minus a squared. 1 minus 0, 0. Minus 1 minus a squared here. And row 5 minus row 2. So that's going to get us 0 here. 0 minus a squared is negative a squared. 1 minus a squared is, 1 minus a squared. And 1 minus a squared is 1 plus a squared. So that's quite good. And now, let's see if we can fix this odd behavior right there. Right, so because I see there's a similarity between row 5 and row 4, it's just missing a 1 there. I want a 1. I'm going to get that 1 from row 3. So I'm going to do row 5 plus row 3 to row 5. And that's going to be nice because, well, we're going to get this 1 back. But this a squared here is going to cancel with the negative a squared. So that's just going to be 1. And 1 plus a squared plus 1. That is 2 plus 2a squared. There we go. Oh, I also forgot to do these steps for the augmented bit. So, row 4 minus row 1, that does nothing. Row 5 minus row 2, well, there's zeros anyway, so that does nothing as well. Row 5 plus row 3, that does 0. Well, that does nothing. So, we're fine so far. But now, because I see that row 5 is really similar to row 4, and we can clear this out, we're just going to do row 5 minus row 4 into row 5. So, these two are going to go to 0. 2 minus minus 1 is 3. 2 minus minus 1 is 3. So this is 3. And we're going to do it to the augmented part as well. So row 5 minus row 4. Finally, that's minus 1. And there we go. That is it. Done. And to make row 4 nice as well, we're going to do row 4 minus 1 minus a squared times row 3, because that will clear this 1 minus a squared here into a 0. And 1 minus, so on the D column, we're going to get 1 minus a squared times a squared. So what's that going to get us? 1 minus a squared plus a to the 4th. Yeah. And on the E column, we're going to do minus 1 minus a squared minus 1 minus a squared times a squared plus 1. And if we switch this and negate the sign, this is a difference of 2 squares, so that's minus 1 minus a squared plus a to the 4th minus 1. So that's going to get us minus 2 minus a squared plus a to the 4th. And do we have to do anything to the augmented bit? No, because row 4 minus 0 is just nothing. So there we go. I don't know why I got rid of that thing, but well, might as well get rid of these while I'm at it. So there we go. That's our row echelon form, and we'll solve for the coefficients now. Not the coefficients. Stop saying coefficients. Unknowns. Okay. So this tells me that 3 plus 3a squared times e is minus 1, which implies that e is negative 1 over, I can factor out of 3, a squared plus 1. There we go. That's the easy bit. Now we have to do this. Okay, so that tells me 1 minus a squared plus a to the 4th d plus this bit times e, but e is negative, so negative 3a squared plus 1 times a to the 4th minus a squared minus 2. Hope you can see I just like reordered that. This is factored into a squared plus 1 times a squared minus 2, this bit. So we can cancel out an a squared plus 1. This equals 0 due to, no, this doesn't equal 0, this equals 1 due to this. So that will get us d times a to the 4th minus a squared plus 1 is 1 plus a squared minus 2 over 3. A squared minus 2 over 3. And because this is 3 over 3, we can combine it to become a squared plus 1 over 3. Right, so a squared plus 1 over 3. And we can divide both sides by whatever that is. So a4 minus e squared plus 1, and get rid of that. So that is our d. And now we just do the exact same thing for c, right? So c, oh, that's much better actually. So c plus dA squared plus e times a squared plus 1. That is exactly equal to 0. And what we're going to do with that, so e times a squared plus 1, that's actually very nice because, look at here, it's going to cancel out to minus a third. dA squared's not very nice. Sorry, I'm missing a bracket there. dA squared's not very nice, but it's still fine. So c plus d times a squared, which is e to the fourth plus a squared, divided by 3 times a to the fourth minus a squared plus 1. Yep, and then that equals 1/3. And so, hold up, am I missing something? No, I'm not. Yeah, so that's going to be 1/3. So c equals 1/3 minus a to the fourth plus a squared over 3 times a to the fourth minus a squared plus 1. And, well, if we multiply this entire thing by a to the fourth minus a squared plus 1 divided by a to the fourth minus a squared plus 1, because, well, that's just 1, but it's kind of like, I don't know, it's cross multiplying, but like not, I don't know what's called. It's just scaling it up, right? But that's going to get a c. So why does that look like an e? That's a c. But c is, well, a to the fourth minus a squared plus 1 minus a to the fourth plus a squared. That's going to be divided by 3 times a to the fourth minus a squared plus 1. Yep, sounds right. And if we flip this sign right here, a fourth is going to cancel out, and we're going to be left with 1 minus 2a squared divided by 3 times a to the fourth minus a squared plus 1. There we go. That is c. Now we're going to do the exact same thing, but to solve for b. So b is going to be b plus a squared c, a squared d, and minus a squared e. So we can factor out an a squared, actually. So a squared times c plus d minus e. That's 0. So we'll just sub everything in. Plus a squared times... So c is this, divided by 3 a to the fourth minus a squared plus 1. D is similar, but that's a squared plus 1. And e is negative. So e is negative, but that's going to become positive because it's minus e, plus 1 over 3 times a squared plus 1, I believe. Yeah. Okay, so that equals 0. And what we're going to do, we're going to factor out a third, because that makes sense to do. Oh god, I just destroyed that. And my thing's going wonky. What is going on here? There we go. Don't know what's going on, but that's that. The denominators look a bit weird now, but like it's fine. We've got a third here. And let's merge these two. So that's going to be b plus a third a squared times, so 1 plus 1, so 1 plus 1, that's, what's 1 plus 1, guys? 1 plus 1 is 2, and minus 2a squared plus a squared, so that's minus a squared, divided by a to the fourth minus a squared plus 1, plus 1 over a squared plus 1, that equals 0. And if we cross multiply, b plus a third a squared, so 2a squared plus 2 minus a to the fourth minus a squared plus a to the fourth minus a squared plus 1. So I just did this times this and this times this and added them together and divided by the product of the denominators, which, because if we recognize that x cubed plus 1, well, we should, because we just use this to decompose minus x plus 1. To decompose the fraction, not decompose. I would not like to decompose. Anyways, if we put in x equals a squared, then this is exactly the denominator, which is a to the 6 plus 1. And some nice things happen in the numerator as well. a to the 4's cancel out. This 2a squared cancels out with these two. And 2 plus 1 is 3. So that cancels out as well. And literally everything cancelled out. And this equals 0. So b is negative a squared over a to the 6 plus 1. There we go. That's b right there. And we can do the same thing for a. So a is ACE, and C and E are multiplied by a squared. So a plus a squared times c plus e, that's 0. And c is 1 minus 2a squared divided by 3 times this. And e is negative 1 over 3 times a squared plus 1. A squared plus 1, not 11. And equals 0. And again, we can factor out a third. Let's factor out a third, please. Factor out a third. And we'll cross multiply. Let's get rid of these brackets. Plus a third a squared. And we'll cross multiply. So that's going to get us a squared plus 1 minus 2a to the 4th minus 2a squared. Yes, yeah. And then minus a to the 4th minus a squared plus 1 divided by, remember, these two multiplied is just a to the 6 plus 1, which equals 0. And if we fix these signs again, so that's minus, that's plus now, a squared cancel out, yep, 1 minus 1 cancel out, that becomes 3a to the 4th, that 3 cancels out with that, so in the end, we get, oh, right, hold up, that's minus 2a to the 4 minus a to the 4th, so that's minus 3a to the 4th, yep, so that's going to get us a minus a to the 6 over a6 plus 1 equals 0. So a is just equal to that. And there we go. We've got all coefficients. I need to stop saying coefficients, but there's no chance for me to say stuff about this anymore because we've solved it, but like, it's fine. So a is this, and we found the other ones as well. So b is negative a squared over a to the 6 plus 1. C was 1 minus 2a squared divided by 3 times a to the 4th minus a squared plus 1. D is a squared plus 1 divided by 3 times a to the 4th minus a squared plus 1. And E is, what's E? E is negative 1 over 3 times a squared plus 1. And so, this is our result for the partial fraction decomposition. And I'm going to end the video here. We're not going to sub it back into this just yet, because I want to sub it in while doing the integral. Because remember, we still have to integrate this. But this is all we're going to do so far in this part. And I hope to see you next time. So, see you soon.